Okay, this is the Trig Practice Test 1. We're going to go over a video here going over the solutions. So I purposefully just got in here and got out so that we could just use the review here. So question number 1, just put in a few words here. You do have to spell the words correctly. All the words will be lowercase. I don't know if that matters or not, but just do them all lowercase. If we're given a rotational angle in the counterclockwise direction, we can take the vertex and move it out 1 unit of length in the initial ray, 1 unit, rotate it around, and the arc length that's there is the radian measure of the angle. If it's going this way, it's positive, and if it's going this way, it is negative. Convert the angle. Okay, so minus 7, number 2, minus 17 pi over 6, that's radians. We want to convert to degrees. That's minus 17 pi over 6 times 180 degrees is pi radians. The pi's cancel, and I can do the rest in my calculator. Negative 17 divided by 6 times 180 is negative 510 degrees. Next question. The degree measure of one complete revolution is 360 degrees, or 2 pi radians. Okay, the next one we're going to be adding or subtracting, actually both, some angles here. So we want to do alpha plus beta. Alpha is 11 degrees 14 minutes 22 seconds, and beta is 7 degrees 25 minutes 33 seconds. Of course we could convert this, but we don't have to. 3 plus 2 is 5. 3 plus 2 is 5. That's not enough. If it gets 60, we'll have to regroup. Okay, 4 plus 5 is 9, 2 plus 1 is 3, and that's 18. Okay, this one didn't have any regrouping. Let me make another one here just to show you what would happen here. What if it was 44 minutes, 38 seconds, 12 degrees, 18 minutes, and 25 seconds. Okay, 5 and 8 is 13. Carry 1 and you get 60 here. Well, 60 is going to regroup and carry 1 here. 8, 9, 10, and 3 more. 4, 5, 6. That's enough to regroup and make 1 degree. 24 degrees. So notice that when we got 60 minutes, 60 seconds here, that made us 1 minute. When we got 60 minutes there, that made 1 degree. Okay, that one didn't show up in this particular one. Now when we subtract, let's do alpha minus beta. So 11 degrees, 14 minutes, 22 seconds. We want to subtract 7 degrees, 25 minutes, 33 seconds. Notice there are more positive than negative, so the answer is positive. There's not enough here, so we're going to take away 1 from here, and that brings over an extra 60, plus this makes 82. Now subtract as normal here, which really you're taking 1 away from here and making 12 here. Alright, so that leaves 9 there, and 7 minus 3 is 4. So that's 49 seconds. And again, there's not enough here, so we have to regroup. So we're going to, or ungroup, break apart here, brings over 1 degree is 60 minutes. So that makes 73 minutes here. And we regroup here. Subtract as normal. That's 48 minutes, and 10 minus 7 then is 3 degrees. And that gets the answer there. Convert to decimals. 65 degrees 33 minutes. That's 65 degrees plus 33 minutes. 33 minutes is 60 minutes for every 1 degree. I need the minutes on the bottom, degrees on the top, so the minutes will cancel. And I can just do this on my calculator. 65 plus 33 divided by 60. 65.55 degrees. Next question, convert the other way, degrees, minutes to seconds. 65.39 degrees. Okay, so that's 65 degrees plus 0.39 degrees. 0.39 degrees I can multiply by 60 minutes for 1 degree. The degrees cancel and I'll be in minutes. So let me do that part. 0.39 times 60. Use a calculator. I could have done it by hand, I guess, but you should use a calculator. 23.4 minutes plus the 65 degrees. Okay, so that's 23 minutes plus the 0.4 minutes will convert to seconds in the same way. 60 seconds is 1 minute. Minutes cancel, and that's 0.4 times that's 24. Seconds. And then we suppress the pluses when we usually write it. And we just write 65 degrees, 23 minutes, 24 seconds. Which is the correct answer. If an isosceles triangle has an apex angle of 64 degrees, so the apex angle, one thing you know about isosceles triangle by definition, these two are congruent, but it makes these angles congruent. So the apex angle is the other angle, that's 64 degrees. Well, we know that's x and x, so we know x plus 64 degrees is 180 degrees. So this is 2x, and subtract 64, that leaves 116 degrees. For the other two, divide that in two equal pieces, that's 58 degrees. Let's see if I did something. Yeah, correct. 58 degrees. Good. If an isosceles triangle has a base angle of 64, so this is 64 and this is 64. Now let's call this guy y. Well, we know 2 times 64 degrees plus y has to equal 180 degrees. So that's 128 degrees. So that only leaves 180 minus 28 is 52 degrees for the apex angle. And if it's equilateral, all three angles are the same measure. And so if they're all x, we have 3x equals 180 degrees. So x is 60 degrees. It's always 60 degrees for an equilateral triangle. So it's also equiangular. Alright, this one you have to do by measuring it out. Okay, so this one you're given the 3 sides. So the way you want to do this, I usually start with the longer side. So 3, 4, 5, 6 centimeters here. And then what you want to do is you want to do 3 centimeters out and make an arc like that. And to do that, you're going to take your compass. So that you start with your ruler and make the 6 centimeters. You're going to set your compass next to your ruler and make sure that it's 3 centimeters there. And make an arc. Then you're also going to set it out to 4 centimeters. So you go through here, 1, 2, 3, 4, and here. And make an arc here. And wherever those two arcs meet, again, use your compass. I'm just kind of freehanding it here. And then that's going to end up finishing it up. So if this is 3 centimeters and this is 4 centimeters. Then you just measure the angles. And it turns out to the nearest degree, this is what the angles turn out to be. So the A is here. So make sure you label things like normal. If this is A, this is A. And this one was B, so that makes this angle B. If this one's C, this is the angle C here. Okay. And so A is the smallest side, so capital A would be the smallest angle, 26 degrees. B is the one in the middle, that's 36 degrees. And C in this case turns out to be an obtuse angle, 117 degrees. And I do allow some a bit to be off. You have to be within 2 degrees of the final answers to get these correct. You're doing that by just drawing it. In general, the triangle, the smallest angle is opposite the shortest side, the largest angle is opposite the longest side. If a triangle is isosceles, then it must have 2 congruent sides and 2 congruent angles. So be sure you know the right words to put if that same question shows up on the exam. Okay, if we're given an acute angle, we can draw a right triangle with this as one of its interior angles. Okay, and then we have opposite side, adjacent leg, and the hypotenuse. Of course, the hypotenuse is adjacent as well, but it's the longest one. So the sine of this angle is the opposite leg over the hypotenuse. The length of the opposite leg divided by the length of the hypotenuse. The cosine of the angle is the length of the adjacent leg divided by the length of the hypotenuse. And the tangent is the length of the opposite leg divided by the length of the adjacent leg. Basic definitions, got to know those for sure. Find exact values for this. The sine of this angle is opposite over hypotenuse, so that'll be 8 over 5 square root of 13, square root of 17, and they want you to rationalize the denominator, so let's go with the arithmetic there. So it's 8 over 5 square root of 17. What we do is we multiply top and bottom by that square root of 17. So we get 8 square root of 17 at the top. Square root of 17 times square root of 17 is 17. 17 times 5 is 85. Okay? Cosine is adjacent over hypotenuse, which would be 19 over 5 square root of 17. Personally, I like it like that, but the computer program is going to want you to rationalize the denominator by multiplying by square root of 17. Again, 5 square root of 17 times square root of 17 is 5 times 17, which is 85, and the top is 19 square root of 17. And tangent is opposite over adjacent, so that's going to be 8 over 19. And this one you do need to use your little palette over here on the side to enter the exact answers. Okay, this one is a right triangle, so we should be able to figure everything out. So if we draw our little right triangle here and kind of label things here as normal. This is A, this is B, this is C. Label in what we know. This is 10 centimeters. Of course, everything needs to be the same unit, but I'll give them to you in the same unit. And then we need to figure everything out, solve this triangle. So I can use the Pythagorean Theorem to find the other side, like this. And this is approximations, so I can do that with my calculator. That can actually be reduced a little bit, but here is the approximation, 11.6619. Now I'm going to store that I can store that as C if I need to get to it later, so I don't have to go back and redo it or figure out all of the different digits and type them in. Okay, now if I want to find angle B, I know that the tangent of angle B is opposite over adjacent, 10 over 6, so B is the inverse tangent of, 6 over 10, I should have said, 6/10. So I can do that, inverse tangent of 6 over 10, and so that's in, I need to see what mode I'm in. I'm in radian mode, so that's the correct angle in radians, but this one's looking for degrees, so I'm going to need to put my calculator in degree mode, and then do the same thing I just did. 30.9638 degrees. Yep, good. Okay, and then we need to find the other angle. Well, these are complementary angles, so all I have to do is 90 minus my previous answer. to find the other one, 59.0362 degrees, rounded to 4 decimal places. And now the only thing we have to do left is find the area, which is 1/2 or 0.5 times A times B, and that's 30 square centimeters. Next question. Okay, similar kind of solving triangle problem. Again, we're going to label it C as our right angle. I'll label these the same way. This time we know C is 14 centimeters and A is 5 centimeters. Again, we can use the Pythagorean Theorem, but this time B is the square root of C squared minus A squared. So that's 14 squared minus 5 squared. 14 squared is 196. 5 squared is 25. 196 minus 25 is 171. And we want this, that's the exact answer, approximately square root 171 is approximately 13.0767, which is what's here. And I want to store that as B, because I want to need B in a minute. In fact, I'll go ahead and use it now. If I take the 1/2 times the A, 5, times the B that I just stored, that'll be the area. 32.6917. And I have corrected this problem so that it will actually round off correctly now at the end. So it does not use the rounded off versions. If you use the rounded off version here, your last digits could be off. Okay, so let's see, we've got the area and all the lengths. We just need to find the angles. The two that we have are, compared to angle B, are adjacent and hypotenuse. So that's cosine. So cosine of angle B is 5 over 14. So B is the inverse cosine of 5 over 14. And I am in degree mode, so this will come out in degrees. Inverse cosine 5 over 14. So 69.0751 or 0.0752, and then just do 90 degrees minus that previous answer, and that gives us the other angle right there. Next question. Okay, another one of these solving right triangles. Big part of the practice test, probably will be a big part of the test too. Will be solving right triangles. Again, same setup. C is a right angle. A up here is 73 degrees here. B, we don't know. We can figure that one out real quickly. 90 degrees minus 73 degrees leaves 17 degrees down here for angle B. So we got that one right away. What else do we know? We need one side. This side is the one we know. A is 7. We don't know B or C. Okay, so let's say with this, the one we know up here, let's use it. This is opposite. So opposite over hypotenuse, A over C, is the sine of angle A. So in other words, the sine of 73 degrees is 7 over C. Solve for C, multiply both sides by C, and then divide by sine of 73. C is 7 over sine of 73 degrees. And we want a decimal approximation, so let's do this. 7 divided by sine of 73. I'm in degree mode, so I don't have to put the degree symbol. And we get that 7.3198, which is what's there. I don't need C for K, so if I wanted to, I could go ahead and store that. I don't really need it again, but I could store it in case I want to come back to it. Okay, so now I have that. I have a couple options now to find B. I could use Pythagorean Theorem, or what I'm going to do is I'm going to use a trig function. Compared to this, I've got opposite, and I'm looking for adjacent. So that's tangent. So tangent of angle A is A over B. So in other words, the tangent of 73 degrees is 7 over b. Solve it very similar to this. Multiply by b and then divide by the tangent of 73 degrees. And so b is 7 divided by the tangent of 73 degrees, and that's 2.1401. I want to store that as b because I will use that again. So now what I want to do is I want to take 1/2 times a, which is 7, times alpha b, so I don't have to type all that again, or I could have said previous answer since it's the last thing I just did, and enter, and there is the area, 7.4904, and it is rounding off correctly, so that's good. Next question. Previous question. Okay, this one. Okay, this one, very similar to the last one actually. C is 90 degrees. This time I know B down here is 51 degrees. Again, subtract 90 degrees minus 51 degrees is 39 degrees, so I've got up here. This time I'm given the adjacent side. A is 7 centimeters. I don't know B or C yet. Okay. So let's find C. So compared to the one we have adjacent, and we're looking for hypotenuse. That's cosine. Cosine of B is adjacent over hypotenuse. Okay, so in other words, cosine of 51 degrees is 7 over C. C then is 7 divided by the cosine of 51 degrees. 7 divided by cosine of 51. We're in degree mode. So that's the 11.1231 for C. I don't need C later, so I'm not going to worry about that. Now let's find B. B is opposite. We're thinking about angle B. B is opposite. This is adjacent. So that if we took the tangent of angle B, we get opposite over adjacent. Plug in the numbers we have. Tangent of 51 degrees is B over 7. Just multiply by 7. So B is 7 times tangent of 51 degrees. And that is 8.6443. That's B. If I'll take that times A, which was 7, and then divide by 2, that'll give me my area K, 30.2550 when you run. Or, yeah, to 4 decimal places, actually 30.2550. Probably you should write it the 0, to show you rounded off to that point. Okay, but actually it'll take it either way, with or without the 0. Next question, 16. Okay, here we go, another one of these things. Okay, so every single case, is showing up here. These may not all show up on the exam, but definitely be prepared for this kind of a question, because it's definitely a big important thing. So we can find angle A right away. It's 90 degrees minus 41 degrees leaves 49 degrees. Now this one we're given the hypotenuse. C is 12. We don't know either side A or B. Okay. Well, we're going to use sine and cosine to find A and B. So let's do A first. A is adjacent, so cosine of angle B is adjacent over hypotenuse. That's A over C. So A is C times cosine of angle B. And notice we don't know A, but we know everything else on this side. 12 cosine of 41 degrees. And we can multiply that, do that on a calculator. 12 cosine of 41. And that is A. I'm going to store that as A, because I'm going to need it later to find the area. 9.0565. Okay, that's what they have here. And a similar way, the sine of angle B is opposite over hypotenuse. That's B over C. So B is C sine of angle B. So B is 12 times the sine of 41 degrees. So that's 12 sine 41. Okay. And so to find that, that's A, so I could store that as A. And so the area is A times B and then divide by 2. And so the area is, make sure I've got these in there right. A, did I store it right? Yeah. B. Oh, I didn't get B stored correctly. Okay. 12 sine of 41 degrees. Store it as B. Alright, that. So now if I do A times B divided by 2, there we go. Something still doesn't look right. B, A. I didn't get A stored right. Why is my storing not working right here? 12 cosine of 41 store is A. Now let's try again. A times B divided by 2. There we go. That's right. 35.6497. Okay. There we go for that one. Next question. Okay, now I think we're going to have a series of real world problems here. You leave your house and run 3 miles due west. Okay, west is going to be to the left on the map. So we leave our house and we run 3 miles due west. So we got north, south, east and west, right? So this is the house. And then you run 2.5 miles north. What's your bearing and distance from your house? So house, if it's from the house, house is the origin. So notice you went north, west. So that angle is the same as that angle. Call that theta. That's also theta. Okay? Well, we know that the tangent of theta is opposite over adjacent. So our theta is the inverse tangent of 3 over 2.5. Inverse tangent of 3 divided by 2.5. So that's 50, well, about 50 degrees. If we round off to the nearest degree, I think it probably tells us that. What's your bearing? North, 50 degrees west. It didn't really say where to round off, but that problem, if we remember, if we have that same problem again on the test, or if you have to do it on a practice test, to the nearest degree, I believe is what we need there. Okay, just got a couple more here. Okay, boat leaves the entrance to the harbor, travels. Okay, so think of us here, north, south, east, west. He's going north 56 degrees east. So this is 56 degrees. This is north, and we turn to the east 56 degrees, and we goes 175 miles. Okay. How many miles north and east is it? So we want to find basically x and y. Now if this is 56, that leaves 56 minus, or 90 minus 56, which is 34 degrees there. So using the 34 degrees, we know the hypotenuse we're looking for the legs. So x over 175 miles is the cosine of the 34 degrees. So x is 175 times the cosine of 34 degrees. And similarly, the y over the 175 is the sine of the 34 degrees. So y is 175 sine of 34 degrees. So we just work those out real quickly here. 175 cosine of 34. That's the how many miles to the east. And that's 145.1 to round it off. We're supposed to do it. and 175 sine of 34 gives us how many miles we went north, 97.9. Next question. Okay, some concept questions here. If two triangles have two pair of corresponding sides congruent, so we got two triangles here, two corresponding pairs of sides congruent, and the pair of included angles, that's side, angle, side, do the two triangles have to be congruent? That is, yes, they do. True. If they have all three pair of corresponding sides congruent, then the two triangles must be congruent. True. That's a side, side, side condition. We know that's true. If we choose any two positive lengths for a side triangle, a proper angle for the included angle, okay, so you go out here a certain length here, and you do it at a certain angle, there's only one choice to finish up your triangle. So there's exactly one triangle, and there's no way you can mess it up. If we choose any three lengths, there's either 0 or 1. If you choose a length here and a shorter length and a short length here, there's nowhere you can put it. Rotate that where those will meet. But if you do rotate them where they'll meet, there's exactly one triangle. Which does not guarantee, okay, congruence, side, side, side does, this does, that does, that does. Side, side angle has the possibility of the ambiguous case where there are two possibilities, which does not guarantee but makes similar triangles, the angles. If you get the angles matched up, you get similar triangles, which is what makes trigonometry work. Which of the following always guarantees the existence of a triangle regardless of the measurements chosen, side, angle, side? Any of these others, there's ways to mess it up. The ones with the two angles, if you pick two angles who already add up to more than 180 degrees or 180 degrees or more, it's not possible to make a triangle. If you there's ways with the side angle to make it where you're given an angle here, given a side, and if this side is too short, it won't reach. So that's not possible. And I already showed you where the side doesn't work. But side, angle, side always works. Pick an angle. Start with the angle. Once you've got a vertex, you've got an angle. Pick a length here, pick a length here. There's always going to be points out there, and you can finish your triangle. And that is the solutions to the practice test.